Okay, guys, for this lesson, we're going to talk about functions being odd, even, or neither. Most functions are neither odd nor even. So, an odd function graphically is symmetrical about the origin. To be symmetrical about the origin just means if we had a rotation of 180 degrees, our graph would look exactly the way it does before we rotate it. So that's what it means to be symmetrical about the origin. So let's take a look at a few graphs. So here we're going to look at the parent function of the linear family, y equals x. This is an odd function. Let's look at that function when we have a negative slope, y equals negative x. Now let's take a look at the cubic parent function. This is going to be y equals x cubed. And then when we have y equals negative x cubed, it slopes downward and it goes through the origin, kind of flattens out right at the origin. That's y equals negative x cubed. So those are 4 examples. And I want us to look at the degree of each of these. So this has a degree of 1. This has a degree of 1. This has a degree of 3 and a degree of 3. So the first criteria for a function to be odd is the degree must be an odd number. So we have a choice. This function is either odd nor neither, odd nor even, and so forth. So know that the degree, your largest exponent, must be an odd number before it can be an odd function. Now, just because it's an odd degree does not mean it is odd. Okay, now let's take a look at what the function notation looks like to be odd. So if a function, the positive x, f of x is equal to, and then I plug in the negative x value, the outcomes are opposite of each other. So remember, f of x just means our output. So if I'm looking at the positive and negative x, their outcomes, their outputs are opposite of each other. So let's take a look at some actual ordered pairs that could represent an odd function. So if I look at the positive 4 and the negative 4's outcome, the outcomes need to be opposite. This one is negative, this one was positive. So if this outcome is negative 9, this outcome or output needs to be the opposite, a positive 9. So your outputs need to be opposite in sign. If we had negative 7, and then we looked at the output of positive 7, the outputs of these 2 ordered pairs need to be opposite. So if this is, say, negative 3, then this output needs to be positive 3. They need to be opposite. That's what this notation is telling us. Okay, to be even, the graph needs to be symmetrical about the y-axis. So if we were to fold our graph along the y-axis, the left side and the right side would mirror one another. So let's take a look at some graphs that are even. So we have our parent quadratic function, and that's y equals x squared. Then if we reflect that across the x-axis, we're going to have y equals negative x squared. And then if we can do y equals x to the 4th, and it's like the parabola, but it's a little bit more squatty or flatter at the bottom. So And then if we reflect that and it's flatter at the bottom, this is going to be y equals negative x to the fourth. So we can see here is our line of reflection on all of those. If we were to fold this graph along the y-axis, this left side would mirror the right side. So here we can see that the degree of each of these functions are even numbers. So our two choices here is this function is either even or neither. So first of all, the first criteria to be even is the degree must be an even number. But again, not all even degree functions can be considered to be even. So let's take a look at this notation. Okay, so this time, let's go back to the red. If I look at the positive x outcome and the negative x outcome, the outputs, f of x, f of negative x, these are both the same. They're both positive or they will both be negative, but they are the same. So let's take a look at some ordered pairs. So we'll just use these ordered pairs. So we're going to look at 4 and negative 4. So this time the outputs have to be the exact same. So if this were negative 9, this output has to be negative 9. So they have to be exactly the same. If we have negative 7 and 7, if this were a negative 3, this output would need to be a negative 3. They have to be the same. Now, before we move on, I just want to go back up to the top and talk about how this graph is odd. So symmetrical about the origin, again, if I were to rotate this 180 degrees, this part that's in quadrant 1 would now be in quadrant 3, and this that's in quadrant 3 would now rotate and be in quadrant 1, and our graph would look exactly the way it does now. So if we were to rotate it 180 degrees, same thing with this one. This part of the graph is in quadrant 2, and if I were to rotate it halfway around 180 degrees, it would look like what's in quadrant 4. And what's in quadrant 4 would look like what's in quadrant 2. So it would look exactly the way it does before we rotate it. And that's what it means to be symmetrical about the origin. So to be neither, neither of these occur. We don't have the same outputs as an even, and we don't have opposite outputs as we do in odd. So let's highlight this a little bit. So odd, our outputs are opposite in sign. For even functions, our outputs are exactly the same. So to give an example, if I look at 4 and negative 4, these are not going to be exactly the same, and they're not going to be opposite in sign either. So like 8 and I could just say negative 2. So to be neither is just, it does not follow the rule to be odd or the rule to be even. So now let's take a look and do some examples in our table. Now I need to make just a few adjustments right there. Okay, so if you were given a table and asked if this could possibly be odd, even, or neither, we can take a look at the negative 1 and positive 1, the outputs of those, or we can look at the outputs of negative 2 and 2, just whatever pair you have. So if we take a look at the negative 1 and 1, these are the same. And also, if we looked at the outputs of the negative 2, these are the same. Therefore, we could say this is an even function. Let's take a look at this function table. Again, you can choose whatever pair of opposite x values. So if we take a look at the output of negative 1 and positive 1, these are opposite. if we look at the output of -2 and +2, these are opposite in sign. Therefore, we could say this function is odd. Okay, let's take a look at -1 and 1, or we have the choice of -2 and 2. And again, we're looking at their outputs. So if I look at this output and this output, I'm going to describe this as being totally different. Okay, so this tells me this is neither even